Hello and welcome to Replify. I would like to take a few minutes of your time to tell you about Replify's application acceleration technology, delivering usability to remote and mobile workers. Let's start with some context. Corporate data networks are evolving. There are three distinct trends at the moment. Firstly, server and site consolidation as companies seek efficiencies. Secondly, the rapid growth in software as a service and the migration of corporate applications into the cloud. And thirdly, ever-growing numbers of home workers, mobile workers, and offshore workers. Yankee Group estimates that ICT workers are typically working 23 hours per week away from the primary office. The net effect of these trends is that nearly everyone has to spend a proportion of their time accessing applications across the wide area network, and in many cases these are systems originally designed for LANs. We're also seeing the nature of the applications change. Richer applications with more interactivity, deployment of knowledge-centric case workflows, and more collaboration between dispersed teams made possible by technologies such as Microsoft SharePoint. So, more and larger content and more interaction. Over the last decade, this has driven demand for WAN acceleration technologies. Over 40% of U.S. corporations have deployed some form of WAN optimization. This has been in the form of hardware bump-in-the-wire devices, providing WAN acceleration for site-to-site connections. But this is no longer sufficient. The solutions on offer have been expensive and inflexible, and the needs of individual remote and mobile workers have not been met. Until now. Replify has a unique proposition which we call Remote Application Usability, which combines the benefits of traditional WAN acceleration with a software-only delivery which can be applied at site and/or individual PC level without interruption to service. We provide seamless on- and offline working, application-specific optimizations, and at a fraction of the cost of a hardware solution. We also offer a rental pricing model for managed service providers. In practice, this means that we can provide remote users with the level of usability experienced within head office, deploy within hours without disruption to existing work, and reduce the traffic on the wide area connections by up to 90%. Sounds good, doesn't it? So how do we do it? Let's look at the underlying problem. There are two issues with accessing applications, data, or web pages across a WAN. Firstly, the bandwidth of the connection, which can throttle data transfers, particularly if many users are contending for the link. On the LAN, you'll likely have gigabit Ethernet. Over the WAN, you may have 5 megabits or less to be shared among many users, or perhaps 500 kilobits of bandwidth for a single user accessing over a 3G network. Equally impacting is the latency of the link, the round-trip time. For a LAN, this is normally less than 10 milliseconds. But for a WAN, this could be 200 milliseconds or more, and the result is that chatty network protocols such as those used in file transfers become painfully slow. Large documents can take many minutes to be received. The users are unhappy, the IT department gets complaints, and time and energy is wasted. The solution is to deploy the Replify Accelerator in the form of a virtual appliance running on standard commodity hardware in each site, and in the form of a PC client for any laptops which may roam. With Replify Accelerator deployed, access times are greatly reduced, the bandwidth demands are greatly reduced, and both of these save you money. Here's a typical deployment. A virtual appliance, or VA, in each data center, and a Replify client in each roaming laptop. You'll also see the Replify Enterprise Manager, or REM, which provides a single point of management and monitoring. Let's look at what these VAs and clients are doing. 3 complementary optimization techniques are in action: protocol optimization, deduplication, and compression. Firstly, protocol optimization. We understand that underlying protocols transferring data across the wire, and so we can eliminate the chattiness, prefetch data, and redundant calls across the WAN. Secondly, deduplication and caching. Our XDR engine watches the data on the link, creates fingerprints for blocks of data, and if that same data block needs to be sent again, a short reference to a cached copy can be sent instead. This approach has many advantages. It's bidirectional, so if something has been sent in one direction, it can be accelerated next time it crosses the link, regardless of which direction it's going. It doesn't matter what application is transferring the content. A document received as an email by a user can be uploaded to a SharePoint site or dragged to a file share, and it will be accelerated on the way. Even if the content is modified, for example, a document is edited, the vast majority of the individual blocks are unchanged, and so only the changed data need to be sent when the document is transferred across the link again. Let's look at this in action. Say we have a user requesting a document through their web browser. If this is the first time the content has crossed the link, we go through a learning phase where both the sending VA and the receiving client learn the content and cache the data blocks. Now the user edits the document and uploads it. What gets sent across the WAN is references to the unchanged blocks, plus any new blocks, and the effect is a huge reduction in the data transfer. Okay, the third and final technique, compression. We simply zip the data emerging from the previous phases before sending it. This produces very significant further gains for verbose encodings such as HTML and XML, and for documents. All this will start to make sense when you see it in action, so let's get to a demonstration. We're going to use a completely real situation. Replify, like many companies, is embracing cloud computing. We're hosting our corporate SharePoint, Exchange, and other applications on third-party platforms. In this demo, we're using Amazon's platform. We've selected 2 virtual servers from their farm and then dropped a SharePoint server image onto one and a Replify VA from the Amazon library onto another. Let's see what the user experience is like. We've disabled the Replify Optimizer client for now. Here's a simple corporate SharePoint site sitting in the cloud. We've created a document library. We've a sample document, The Complete Works of Shakespeare. It's about 7 megabytes in size. Let's save it to a local folder and see how long it takes. Was painful. About 40 seconds, and it wasn't even an especially large document. If you're an architect, designer, or a publisher, you'll be working with much larger files than this. Let's turn on the Replify Optimizer client. We'll also clear the cache so that we can see the performance while the client is learning new content. You'll notice checkboxes for several protocols. Replify can be configured on both a per protocol and per application basis. Okay. That's the cache cleared. Now we'll close down the browser sessions just to make sure we have a clean connection, and then open up our SharePoint site again. Here's our sample document. Let's save it as before, but we'll give it a new name so that we can see what's going on. Okay, 8 seconds, about 1/5 of the first download time. And remember that at this point we're only learning the document, so the benefits we're seeing are from the protocol optimization and compression phases only. This is one of the monitoring screens in the remote virtual appliance sitting in the Amazon data center. The red graph represents the effective data across the accelerated link, and the yellow graph, the actual data sent. You can see a very impressive reduction already. Okay. Let's download that file one more time. And this time the download is almost instantaneous. Back to the VA. As you can see, only a tiny amount of data was actually sent across the wire. And here we can see that about 85% of the traffic is being removed from the WAN connection. Or, put another way, it now has about 7 times the effective bandwidth of the bare link. Let's prove my point about the advantages of Replify's XDR engine. I'm going to edit the downloaded document. Open the document. We'll add some text. Then we'll delete some. And finally, we'll save it with a different name. Now, any other caching technique would be totally thwarted by any one of these changes. We're going to upload this to our SharePoint site. We browse to the document and select it. Now we hit OK. The green progress bar pauses for a moment. This is SharePoint carrying out some authentication steps. But once the download begins, there it goes. Almost instantaneous again. And here's the document in our library. One important point I should make is about security. This accelerator only operates at the data transport level. All decisions about access control and permissions are made by the applications as usual, so we don't compromise security. We also work above the VPN level, so we don't care or notice whether there's a VPN present or not. We've focused on explicit downloads, but even viewing a web page or an on-screen report can involve the transfer of large amounts of data, and Replify will treat it in the same way. This page has a 6 megabyte image in it, but it loads instantly. For users in a site with a Replify virtual appliance deployed, the cache is shared, so as content is learned, everyone gets the immediate benefit. To finish off, let's open up a file share. Like SharePoint, this file share is sitting on a remote server in the Amazon Cloud Data Center. Here's another version of our Shakespeare document. Let's drag it to a local folder. This file transfer is being handled by a protocol called CIFS and not by HTTP as in the SharePoint download. Even so, because the content is the same, our application acceleration kicks in and the transfer takes only a couple of seconds. So to wrap up, the accelerator provides remote users with the application usability of a worker in head office, can make your WAN connections appear up to 10 times fatter, and do this in minutes without deploying specialized hardware. Thank you.